All right, in this problem, we want to find the vertical asymptotes for these functions, and then we want to look at the limits, what's happening as x approaches the asymptote from the left or the right. All right, so now there's A, B, C, D, so this video might be a little bit long, but feel free if you think you've got the idea and you just want to try them yourself, then pause the video, do them yourself, fast forward through to check your answers, and that's fine with me. So. All right, first thing I'm going to do, I really am interested in where the denominator is 0. So I'm going to factor the denominator of this function, right? So I get x times x minus 2. And then based on that, I can see I'm going to have vertical asymptotes at x equals 0 and x equals 2. X equals 2. Okay. Right, because there's nothing that cancels now. If there was something that canceled from the numerator, then I wouldn't have a vertical asymptote. But there's nothing that cancels, and nothing more I can do to simplify this. So I get these vertical asymptotes whenever the denominator is 0. All right, now let's look at the limits. Okay, so let's take the first vertical asymptote at 0, and I'm going to look at the limit as x approaches 0 from the left first. And I'm just going to go ahead and write this x times x minus 2. Okay, that's my function in factored form, because I think that will help me. Now, the numerator is always positive. Okay, so I know it's going to go to infinity. I just need to know if it's going to go to negative infinity or positive infinity. Right? The numerator is 1, and that's positive, so that's always positive. Now, when I'm approaching 0 from the left, those are negative numbers, right? So x is going to be negative, all right? And if I take a negative number and subtract 2, that's also going to be negative. Okay, so I'm just going to put the signs of those factors in, and then I'm going to evaluate the sign of this limit. All right, so I have a positive in the numerator, and negative times negative is positive. Positive over positive is positive. So this is going to go to positive infinity as x approaches 0 from the left. All right, so let's look at what happens as x approaches 0 from the right. All right, again, we have 1 over x times x minus 2, and I'm just going to look at the signs. The numerator is positive, right? Now, we're approaching from the right. They're approaching 0 from the right, so these are positive numbers. So x is positive. And remember, we're near 0, right? So we're something less than 2. We're looking at getting closer and closer to 0. It's positive, but when I subtract 2 from it, it's going to be negative. Okay, so I'm just again putting the signs in there and evaluating the sign of the whole function near 0 to the right of 0, right? And so I have a positive over a negative, so this is going to go to negative infinity. All right, and then I can do the same thing with the other vertical asymptote. Let's look at the limit as x approaches 2 from the left. And our function is 1 over x times x minus 2. And the numerator is positive. And, okay, we're approaching 2 from the left, but it's going to be x is positive. And x minus 2, right, if I take something less than 2 and subtract 2, it's going to be negative. Okay, so this goes to negative infinity. All right, and then the limit as x approaches 2 from the right, all right, we're going to have the function is 1 over x times x minus 2. All right, numerator is always positive because it's just 1. X is positive, right, because we're approaching 2. And now if we're approaching from the right-hand side, something a little bit bigger than 2, or that something bigger than 2 minus 2 is going to be positive. All right, so this is going to be positive infinity. All right, there you go. That's the first one done. I'm going to go ahead and do the rest of these, and feel free to skip forward, do them yourself if you want to. The first step in all of these is just going to be to factor And this one's a little bit different though. No, not yet. I got another one. There's a couple of these that are a little bit different. So let's go ahead and do this one. So first thing I'm going to do is factor it and see what I got. Now, if I can factor the numerator, I want to, because sometimes there are factors in the numerator and the denominator that match, and then you can cancel them. So let's see. The numerator factors into what? X minus 3 times x minus 4, right? And the denominator factors into, I need factors of negative 10 that add to 3. So x plus 5 and x minus 2. Okay, that works out. Now, I don't see anything that cancels, so there's no wholes. What happens is if you have factors that cancel, you get a hole in the function at that point. So we'll see an example of that in a minute. But I have a vertical asymptote. Vertical asymptote, add x equals wherever the denominator is 0, right? So x equals negative 5 and x equals 2. Okay, those are my vertical asymptotes. All right, now we're just going to evaluate the limits. All right, so we're going to do the limit as x approaches, let's do the negative 5 first, and we're going to approach from the left. Now I'm just going to write f of x because I don't want to write out all the whole thing. But I can see that the factors are. Now I'm near negative 5, right? So I'm going to look at the factors in the numerator. Now here I could just put in a negative 5, right? So I can just put in, this would be a negative 8. But it doesn't matter. All I want is the sign because I know it goes to infinity because I have a vertical asymptote. All right. So this is the first factor here is going to be negative. And this factor is also going to be negative, right? Because if I put in negative 5 in either one of those factors, I'm going to get negative factors. Now, the x plus 5. Now I'm to the left of 5. So I'm a little bit more negative, like say negative 5.1, and if I add 5 to that, right, I'm going to get something negative. Okay, and then here x minus 2, that's going to be negative. All right, so all my factors are negative, but negative times negative is negative, right? And then so I have positive over positive, so this is going to go to positive infinity. All right, and let's do the same thing. Limit as x approaches negative 5 from the right of f of x. Okay, and again, I'm just going to evaluate those factors. Now, because that's negative 5, the numerator is really going to be the same, right? And the only thing that's going to change is that x plus 5 factor, right? So now I'm to the right of negative 5. So something a little bit bigger, or sorry, well, let's be like negative 4.9, right? So this is going to be positive now, and this is still going to be negative. All right, so it's going to change the sign. We're going to get positive, negative times negative is positive, but then the denominator is going to be negative, right? So it's going to be a negative infinity. All right, let's keep going here. Let's look at the limit as x approaches 2 from the left. And I'm just going to write f of x, and then I'm going to look at the factors. So now it's 2. 2 minus 3, all right, that's negative. 2 minus 4, that's negative. All right, so the numerator is still negative times negative, which is positive. And 2 plus 5, okay, that's positive. And then now I'm to the left of 2, so like 1.9, right? 1.9 minus 2 is going to be a negative, right? All right, so now I can evaluate these signs. I have positive over negative, and it's going to be a negative infinity. All right, and let's look at what happens as x approaches 2 from the right. All right, so the numerator, sorry, doesn't change. It's negative, negative. The only factor that's going to change is that x minus 2 factor. All right, and now I'm a little bit bigger than 2, so maybe 2.1, right? 2.1 minus 2. is positive. Okay, so I have a positive numerator and denominator, so I get a positive infinity. There we go. All right, 2 down, 2 to go. All right, this one I think is a little bit different. Again, I'm going to start by factoring, right? So let's see, this factors into what? X minus 2 and x minus 3, right? That'll work. And then this looks like it's the same denominator I had before. Well, yeah, it's the same denominator I had before. So it's x plus 5 and x minus 2, right? Now, in this case, notice that we have a factor of x minus 2 in the numerator and the denominator. So I can cancel it as long as x is not equal to 2. So I have to keep that in mind. Everywhere else, when x is not equal to 2, it's going to look like x minus 3 over x plus 5, all right? At 2, it doesn't exist, so it's undefined at 2, so we have a hole at 2. So in this case, we only have one vertical asymptote at x equals minus 5, and we have a hole at x equals 2, all right? So it's going to look, this function looks like x minus 3 over x plus 5 everywhere except at x equals 2. The limit even, right, as we approach x equals 2 from either side, right, it's going to look like x minus 3 over x plus 5. But we're going to have a hole at 2. Okay, so now we only have one vertical asymptote, so we only have to do one limit in this case. So let's look at the limit as x approaches negative 5 from the left of f of x. Okay, so let's look at the factors. The only factor we have left is the x minus 3. We put in negative 5, so the numerator is going to be negative. Okay, and if we approach negative 5 from the left, right? So maybe negative 5.1, right? Then this is going to be negative. Okay, so this looks like it goes to positive infinity. And the limit as x approaches negative 5 from the right. Okay, the numerator is still going to be negative, right? Because negative 5 minus 3 is negative. And now we're approaching negative 5 from the right. The denominator is going to be positive. And so this is going to be a negative infinity. All right, one more to go. Now, this one, let's again factor this denominator. So I have 3x. I can't really do anything with that. I know I can factor out an x in the denominator. And then, let me just write it down here. X squared minus 6x plus 9, right? And I can factor that. And it looks like x minus 3 times x minus 3 would give us the x squared minus 6x plus 9. So this is going to be x minus 3 squared. All right. Now, we have an x in the numerator. We have an x in the denominator. Those will cancel as long as x is not equal 0. All right. So we're going to have a vertical asymptote at x equals 3. And we're going to have a hole at x equals 0, right? We have a hole in the function. Everywhere else it looks like 3 over x minus 3 squared. Okay. Now you can probably guess what's going to happen as we approach the vertical asymptote, because if we take, if we cancel out that x value, the numerator and the denominator are always positive, right? So, but let's go ahead and write it out. Limit as x approaches 3 from the left. I'm just going to write f of x so I don't have to write the whole function out. And then I'm going to look at the factors. I'm going to ignore the x factors because I'm approaching 3, not 0, so I don't have to worry about that. Those will cancel. And so I'm going to have a positive in the numerator and a positive in the denominator, so it's going to go to positive infinity. And the limit as x approaches 3 from the right, all right, the numerator is going to be positive, and the denominator, right, we're squaring it, so it's going to be positive. So in both cases, it goes to infinity. Okay, so there we go. That's all I have for you, and we'll see you in class.